Hey there, geometry team. Welcome to Unit 7, and we are starting off day 1 with just a very basic overview and reminder about what the heck quadrilaterals are. You got to spend the last couple units focusing just on triangles, on our little three-sided friends, but now you're ready for the big leagues. We get to start doing more sides. So going straight into our quadrilaterals, reminder to you that quadrilaterals simply are four-sided polygons. Okay? So they have four sides, they have four angles. That comes from quad, which means four, and lateral, which means side or line. Okay, and so we've got our quadrilaterals, and we're focusing just on four-sided shapes to get us started, but don't worry, later in the unit we get big. Okay, so we've got our quadrilaterals, and so you think, well, there's a whole lot of ways you can draw things with four sides. And so we start off with the most basic, generic, think of a thing with four sides, but nothing special. So it doesn't have anything that's the same length, and it doesn't have anything that's parallel or anything like that. And so those two things give you some kind of random four-sided shape. It could be something like that, okay? Or it could be something like this, okay? And these have neither parallels nor congruent sides, and these are just boring, old, irregular quadrilaterals. Okay, so they're irregular, they don't do anything fancy, and there, I wrote it, just in case you wanted to see it. Okay, so we have our irregular, nothing regular about them, nothing special. I put these in this biggest outer black box because this box includes anything that's got four sides. These guys are on the outside because they don't get to belong to any of the special subgroups. They are just unspecial. This one happens to be concave because it has a part that goes in. This is convex. We're not focusing on that. I just want you to see that they exist. We're going to focus strictly on the convex ones where nothing caves in on any of the sides. So cool, we've got four-sided shapes. Well, those four-sided shapes can be broken down into a lot of categories. So you think about, okay, well, what could I do special to a four-sided shape? Well, the first thing you could do is you could decide, okay, maybe some of the sides are the same length. Okay, so if you decide to do that and make some sides the same length, you have to decide whether those sides are next to each other or opposite from each other. And so we're going to start with the ones that are next to each other. If you make a quadrilateral have two adjacent sides congruent, that is going to give you something that's called a kite. And what makes a kite is two adjacent sides will be congruent, okay? So they're going to be congruent, but also if the two sides that are adjacent are congruent, so like say if I were to draw a four-sided shape and tell you, okay, I'm going to start with these two sides being congruent, then interestingly enough, if these two sides decide to be congruent, automatically the other two adjacent sides have to be congruent. So this actually has both sets of two adjacent sides being congruent. So if these two are congruent, these two are as well. And that ends up looking like your classic kite that you made when you were a little kid. You flew it up in the sky, unless you bought the crappy ones from the dollar store and they were just shaped like a triangle. Okay, so this is a kite. All right, it has no parallels in it. So nothing in here gets to be parallel. So, kite. Two sets of congruent adjacent sides, but no sides are parallel to each other. So that's your kites. Notice that these are regular guys that we talked about back in the beginning. They don't belong to this set because they don't have any congruence. That's why they were not included in this special little red box here. Okay, erase some of this junk out of the way so that we can focus then over here. Well, here we have things that had no parallels. Now I'm going to focus in on, okay, well, what if there are some parallels? Well, I could have two sides parallel or all four sides parallel. So we're going to start simpler and stick with the just two sides parallel. So if you have only two parallel sides, only two sides are parallel. All right, only two parallel sides is going to give you, and I hope you've already remembered it, this gives you your trapezoids. Fun fact that I learned just this week is that like in everywhere in the entire world except the US and Canada, they call these trapeziums. Who knew? But we call them trapezoids because we do everything different here. So we've got our trapezoids, and what they have is they have only two sides parallel. And you notice I have this big green box with a little box inside it. So I'm going to start here with the biggest box and say anything with two parallel sides is a trapezoid. And so it could be something like, say, this, okay, where this top piece is parallel to the bottom piece, but the other two don't have anything special going on, okay? This could have zero congruent sides. It might have some congruent sides. We don't know. All we know is that two sides are parallel. That makes it a trapezoid. As opposed to over here, these guys don't have any parallels when they're kites. So one set of sides parallel is a trapezoid, none is a kite. So cool. Well, if you decide to get special in these trapezoids, you might say, well, what if I pushed it around and made it so that two of the sides were congruent? This definitely does happen. You could have something that looks like this, where, okay, the top and bottom are still parallel, but I've centered, and that drawing was terrible. You know what, I'm going to redo that one. That's better, that's more centered. Okay, so these two guys are still parallel to each other, the top and bottom are, but the two legs here, I'm going to make them be congruent to each other. So I still fit the definition of a trapezoid. I still belong in the green box, but I'm even more special here because there's two sides that are congruent. They are opposite to each other instead of next to each other like they were in the kites. This is an isosceles trapezoid. An isosceles trapezoid, it almost looks like an isosceles triangle did, but with the top chopped off. Okay, and all it means is that there are two congruent opposite sides. Okay, so it's a trapezoid, meaning it has one set of sides parallel, and since it's isosceles, it also has two sides that are congruent. Now, you could flip this over on its head and have it be upside down. That's going to be the same thing. Remember, all these rules apply no matter how the shape is oriented. So be careful that you don't get tricked by if we turn things sideways or at an angle. So we've done our isosceles trapezoid, which is just one of our special trapezoids, and we've done our kites. These are things that either have no congruent sides, but they have, no parallel sides, but they have some stuff congruent, or they have one set of parallel sides. Okay? Well, then you think, well, what if there's more than one set of parallel sides? What if all the sides are parallel to something? And that's when we move up here. So I'm going to erase some space here and move this fella up. Come here, buddy. Nope, I don't have a PowerPoint on this one. I just have my one page, which means I'm fighting with... There's my mouse. Where's my mouse? Come back. There you are. Now we can come back here. All right. So now, again, we're still talking about just quadrilaterals with four-sided shapes. This great big box, you notice, is still part of our quadrilaterals, friends, but it's different than these trapezoids down here and the kites were. So remember, we had our kites, which had just congruent sides, and we had our trapezoids, which had a set of parallel sides. Now we're going to talk about ones that have two sets of opposite sides are parallel. And you notice I used the parallel symbol because why write out the whole word when you know a symbol that works for it? So I've got two sets of opposite sides parallel. Well, two sets of two gives you all four sides. So another way some people say this is all the sides are parallel to something. And so if it's about things being parallel, to help ourselves out, we put that in the name. So anything that quadrilateral that has two sets of parallel sides is going to be a parallelogram. And so there's your word parallel, but now we've tossed in ogram into it so that, it sounds all spiffy. So a parallelogram is just a kind of quadrilateral that has two sets of opposite sides parallel. And that's your classic kind of slanty fella there. And one set of sides here, the top and bottom set of bases will be there. But if you flip it on its side, these bases are also parallel. But they're not parallel. So these two are parallel and these two are parallel. So two sets of opposite sides are parallel. So fun fact about this is that if you've got two sets of opposite sides parallel, you'll also have two sets of opposite sides will also be congruent. And we actually could prove that using all of those parallel properties with alternate interior angles and alternate exterior angles and isosceles triangles and all that stuff we've done before is used to prove this fact. Okay, so that's why that's not included in the definition. The definition is just that the opposite sides are parallel. But straight from that comes that the opposite sides are going to be congruent. Okay? And you notice we didn't talk about anything with angles there. Because this just talks about sides. Now, if you start wanting to get spiffy with whether sides are congruent or where the angles do certain things, that's when you get into these special little subsets that we're going to run through here. So let's say you take a parallelogram and you decide I'm not going to do anything to the angles. It could be any old angle it wants to be. Something like that. It could be nice and that, or it could be super duper flat even. Okay. Anything like that. So I decide to make a parallelogram where my opposite sides are still all parallel, but instead I'm going to make this one have all the sides be congruent. So I'm still in my big purple parallelogram box, but now I've come down here to this guy and I've said, okay, I'm going to make it be anything that's got all the sides the same length. Okay? That is going to be your rhombus, which many of you are already heard of. You know about this thing, but now we're expecting you to know that what specifically makes it a rhombus is being a parallelogram, so all its sides are parallel, that has 4 congruent sides. So let's put in here 4 congruent sides. Okay? And you notice this box is big and kind of overlaps this other box, which means this box is something completely different, but we can combine them. So let's come over here to this other box and see, okay, what other kinds of parallelograms are there? We've got the ones with 4 congruent sides. Those are your rhombuses. Over here, we're going to take them and say, okay, what if instead of focusing on how long the sides are, what if I focus on my angles? And specifically, what if I take this guy and make him stand up straight? And tell him to stop leaning back and take it easy. No, stand up straight. Well, that's going to make him look kind of like this, where there will be right angles. And if one of the angles is right, all of the angles is going to have to be right in a quadrilateral because proof reasons that if you want to do the proof, come see me, we'll do the proof. Okay, so if you take a parallelogram and give it all right angles, well, we need to name it something special because that's what we do in math. And so parallelograms with 4 right angles are rectangles, which if you know anything about German, they always do things with sounds in them. So instead of right, it would sound more like recht or recht. And so rectangles. And so rectangles just have 4 right angles. Okay? So they are still parallelograms. They're just parallelograms that are standing up straight. How do I know it's a parallelogram? Well, look, this set of sides is still parallel to each other, and this set of sides is still parallel. So I'm still in the big parallelogram family. I'm just special because I'm standing up straight. So that's a rectangle. It's got the right angles in it. And then you go, okay, well, what if you have a rectangle that happens to have 4 congruent sides? Or, for a good time, what if you have a rhombus that decides to stand up straight and have right angles. Well, that's where you end up in this middle box where you think, okay, I needed to have right angles, but I need the sides to be congruent, and I still need it to be, I'm still in my parallelogram box, so I still need these sides parallel and these sides parallel. Notice I have to mark my angles to show that they're right. If it's not marked, it's not true. So I've got my 4 right angles. So here is definitely a rectangle. It's in my parallelogram box. It's got 4 right angles. But it's in my parallelogram box and also happens to have 4 congruent sides, so it must be a rhombus. So this is a hybrid. It's both a rhombus and a rectangle. And there's probably several of you already screaming at your screen, Miss Serna, we know what that is already. That is a square. Okay, so your square is your most specific type of quadrilateral. It's got 4 sides, so it belongs in the biggest box. It's got 2 sets of sides parallel, so it's a parallelogram. It's got 4 congruent sides, so it's a type of rhombus. And it's got 4 right angles, so it's a type of rectangle. And so we call this a square. Now in your assignments, we're going to be typically asking you for either all the names that apply to a particular shape. So if you said this one, you might say, well, this is a quadrilateral, and it's also a parallelogram, but since it has 4 congruent sides, it's also a rhombus. So you should be able to tell all of the different categories it belongs to. Or we might ask you, what's the most specific name for a shape? What name tells you everything about it and how special it is? In which case you would just say this is a rhombus, because a rhombus name will tell you that yes, it's a quadrilateral, yes, it has 2 sets of parallel sides and is a parallelogram, but calling it a rhombus tells you you have 4 congruent sides. Okay, so question, are all squares parallelograms? Well, yes, they're inside this bigger box. Is every parallelogram going to be a square? Well, no, they don't all decide to have 4 right angles and 4 congruent sides. So you need to make sure you can differentiate between them. Okay, team, that's all we've got today. Here's all your basic facts on quadrilaterals, and next time we'll be moving forward into some more specific details that you get to learn. See you then.